Okay, I'll just show how to create the base scenario of the existing pipes and then make a child scenario of that and carry on the designing of the model. Before that, I'll just show you the kind of data I've provided you. This is zone Revati. This is Revati zone, for example. I've just taken just to explain. So as you can see, these are the building parcels which are there in this light green color. These are the building parcels, and these white are the roads, the existing roads in between the buildings. And the red outline will be your zone boundary, right? This is the zone boundary. Okay, and these dots which you can see are the house consumer data, right? Consumer survey data, which will contain your house service connection demands as well. Now these blue lines which you see, these blue lines are the existing pipelines, right? All the blue lines are the existing pipelines, the old ones. For example, if I take this pipe, as you can see, it's an existing AC pipe of 250 diameter, right? And for an example, I can take you this again is a PVC pipe of 90 this again is a PVC pipe of 90 this is an AC pipe of 250 Basically, these are the existing pipes, right? So if I switch off the, yes, I've just switched off the new pipes. So these are the existing pipeline, right? As you can see, there are a lot of roads wherein the pipe is not there, right? These roads do not contain any pipeline, right? So we are going to propose new pipes in all of these roads, right? Which is in this magenta color, right? So these are the new pipelines, proposed pipelines. See all the empty roads which you can see here, these have filled it with new pipelines, right? So the blue is the existing pipeline and this is the new pipeline. So these are two shape files. The existing shape files are like Revati existing pipe 50 meters. 50 meters says that all the pipelines have been cut at 50 meters length to facilitate the Thiessen polygons, right? Then magenta, again Revati new pipes at 50 meters, means all the new pipes, also proposed new pipes, have also been cut at 50 meters to facilitate the Thiessen polygons at 50-meter nodes, right? So this is the data I've provided you. These are the shape files which I've provided you. One is Revati zone boundary, which is the zone boundary. These are the OHT details. In this OHT details you can see the details like what's the northing and easting, the location of the OHT, what is the existing lakh liter capacity, right? Existing capacity in lakh liters, that's 3 lakh liters. What's the staging is 11.57 meters, the current ground level, LWL, MWL, wet surface height of the tank, and the tank height in total, and the outlet as well. Outlet is CI 150 dia, right? So this is the data I've provided, and from here we'll have to do the modeling. I'll just show you how to do the scenarios there. Right, I've just opened WaterGems here, and we're going to import the existing pipes and the new pipes and carry on with our modeling in scenarios, right? So first we just have to have a base scenario. In the base scenario, we'll have only the existing pipes along with their respective diameters and material, right? The base scenario will contain only the existing topology, and then we'll create a child scenario of the base, and then there we'll introduce our new pipes and we'll replace the old AC and PVC pipes with new HDPE pipes, right? So those replaced pipes and new pipes will be there in the child scenario, which will be the 2044 child scenario, right? First we'll go to as you can see in the scenarios, we are currently in base scenario, right? Right, so we'll just import model builder, new, go to ESRI shape files, then select your files here, right? So these are the shapefiles which I've given you. First, in the base scenario, we'll just have the existing pipes. So here, Revati existing, just click on that, click OK. Yeah, so if you click on show preview, it will show the attributes of each pipe in that shapefile. As you can see, diameter M attribute has the diameter of the pipes, and the pipe material has the material, right? So we'll consider these two. So click on next. The coordinate unit is in meters. We'll establish a tolerance for the connectivity of 1 meter. Click on next, click on next, next. Right here, it's very important here to check, as we have to assign the material and the diameter of the pipes to the topology, right? So in the key fields, go to I'll just take label, right? As I said, and we saw earlier, you can even see in this preview. If you click on the preview, show preview, you can see all the attributes and fields of the shapefile. So as I said, the pipe diameter underscore M is the diameter, pipe underscore meter is nothing but the material, right? So pipe diameter underscore M, I'll assign the diameter property, right? Diameter, and the diameter is in mm, so let it be like this. Then the pipe material, select this, click on property, this will be material, right? So the diameter and material is taken care of. Then click on next, right? Click on next. Would you like to build the model? Yes. Click on finish, click on yes. Right, so this is the existing pipeline which will be there in the base scenario. We don't do anything here, just leave it as it is. As you can see, I'll just example, if I take a pipe, if I take this pipe, it is diameter is 90 mm and the material is PVC, right? Leave everything as it is. As in the base scenario, we just need the existing topology in the base scenario, right? 90 mm PVC. If I take another one, this is again PVC 90 mm, this will be AC 250 mm, right? Okay, so we'll have to put it in the pipe table that these are existing pipes. For that, you can just create a new pipe field, go to user data extensions, right click on pipe, and you can add field. So pipe field 1 has been added, so click OK, right? One pipe field has been added. So if you select everything, right click, edit group. If you go to pipe table, as you can see, all the pipes are there, the material, the diameter, everything. And here you can see field, pipe field, right? If you don't get pipe field here, just go to edit and you'll have pipe field here. Just put this add and put it into your table, right? Pipe field 1. I'll just remove notes are not required, so pipe field 1. Okay, right? So pipe field 1 is there. So all these are existing, right? Everything is existing. You can just put it as existing, right? So all these pipes are existing, right? So the purpose of putting this there, the later the client will know that these pipes are existing, right? So click on OK. Yes, so this base scenario is done. All the existing pipes have been put in the base scenario. Then we need to create another scenario, a child scenario of the same, and then do our modeling there, right? So go to scenarios, right click on base, click new, child scenario, right? I will name this as 2044 or 2044, that's it, right? Okay, so 2044 has been created. Now we need to create a separate topology for that, right? So make this active. Okay, so this is the current, we are there into 2044 scenario, right? Make sure you're in the correct active scenario. You need to create the alternatives as well. So if you go to the alternatives tab here, you need to create an active new base topology. You need to create a new child alternative. I will rename this as 2044 topology. When you create a physical child as well, base physical, right click, new child alternative. I'll rename it as 2044 physical. Right, so these, once this has been created, again go to scenarios, make sure 2044 is selected. So let's go ahead and create a child scenario. Make sure in alternatives you have created 2044 topology, 2044 physical. You go to scenario, right click on new child scenario. I will name it as 2044. Right, so click on 2044, make it active. So we are currently in this 2044 scenario, child scenario. Make sure you change the topology of the 2044 scenario as well, right here. So the topology will be 2044 topology and physical will be 2044 physical. Okay, if you double click on this, you will get the properties, or you can always right click and properties, you will get this. Right now, why we change the topology is because if we are there in the current base topology, whatever changes we make here will be reflected in the base scenario, which we don't want to. The base scenario should always be there untouched. So we'll change the topology, 2044 topology and 2044 physical. Now you can go ahead and make your changes and do the modeling in this child scenario, and you can go ahead with that, right? Sorry, so that you can have the base scenario untouched. Right, so currently in this 2044, as I said, AC and PVC have to be replaced. DI, CI and MS pipes have to be retained. So first thing what I'll do is I'll select everything and go to edit group, pipe table. Right, so all the CI pipes I will change it to HDPE. All the PVC pipes I'll change it to HDPE. Okay, in this model, the existing network has just AC and PVC pipes. In case you have CI and DI or MS pipes, just keep it as it is and use it in the model. In case hydraulically the existing pipes are insufficient, then you can use new pipe there and consider the old existing pipes as discarded. So I have replaced all the AC and PVC pipes to HDPE. I'll just do the same thing in the command as well. In pipe field 1, I will global edit and set it as replaced. Okay, I've done global edit because all the pipes have been replaced in this model. That's why everything you will have replaced here. In case you have CI and DI, you have to write retained here because you are retaining that old existing pipe in your new model as well. Right, so remember, CI, DI and MS pipes, you have to retain it, and please add the same comment as retained here in this pipe field 1, since we are retaining it. So once this is done, all our old existing pipes have been changed, replaced to HDPE, and the diameters you can give as you wish when you're modeling it. Each modeler or designer has their own way of assigning the pipe diameter, so you can go ahead with that. Alright, now I'll just show you how the base and the child scenario works here. For example, we are there in the 2044 scenario. If I take this pipe, for example, we have changed it to HDPE pipe. Before it was PVC pipe, now we have changed to HDPE. Right, if I take another pipe somewhere here, again it is HDPE pipe. Right, but if you go to the old base scenario, make it current, if you check here, it is still PVC, right? And here it is AC, here it is PVC. But if you come to 2044 scenario, make it current, or right click, make current, if you see the same pipe has been changed to HDPE. Right, the reason for doing these child scenario is the client, if client or anyone, if they want to know this is HDPE, what was the pipe it is replaced with, what was the existing pipe, if they want to know, all they do is they'll go to the base scenario, make it current, and go click here, and they'll get to know what was the existing pipe and now what we have replaced it with, right? So base scenario should contain only this. So let us go back to the 2044 scenario, right click, make current. So make sure in this your topology is always 2044 physical. Before making any changes to the pipe material or anything, or doing anything in child scenario, make sure your topology and physical have been changed, right? So that doesn't reflect back in the base scenario. Now, as I said, these are just existing. We'll have to add new pipes where there are no to the roads which don't have any existing pipes. We'll have to add new pipes. For that, I've given a shape file. Just model import, model builder again, right? Just delete this, new ESRI shape file. Here I have given Revati new pipes. These are the pipes to the roads which do not have any existing. The new pipes, click open, again click next, click on meters, click on establish tolerance of 1 meter, next, next. Here the key field, just add label, leave everything blank because we have not assigned any diameter or material for that. So click next, next, that's it, finish. Yes, close this, yes. See, as you can see, you've got all the new pipes here, right? For example, these are the new pipes. If you click on this, you can see it is by default taken it as ductile iron. When you import without giving it any pipe material, it will by default take as DI pipe, right? So you can change all the DI pipes to HDPE pipes as well. And for example, if I go here, edit group, pipe table, right? So all the DI pipes are here. These are the new pipes, right? If you scroll to the pipe field, you can see all those are blank, right? So now I need to select all the new pipes, right? Select all the new pipes and select all the new pipes and give a comment as new pipe. Okay, so these are all the new pipes. Right, I'll just do that for everything. So till here, new pipe, right? So don't forget to put this comment in the pipe field one, that these are new pipes. This will indicate to the client whether this particular pipe is new pipe or it's a replaced from other old pipe or anything like that, right? So click close. This is done. For example, now if you check in your base scenario, right, if you go to your base scenario, if you make your base scenario current, as you can see, all the new pipes which you have added has become inactive automatically, correct? You can see grayed out. For example, this pipe, it's become inactive. Is active? False. Okay, this has become inactive. And you go to 2044, this is where you have imported and all, you'll be doing all your modeling and everything here. You go to base scenario, as you can see, all these pipes have been grayed out and made inactive automatically. So leave it as it is, leave the base scenario as it is like this. So let me take this pipe as example. See, if you see here, it is AC PVC pipe, AC 250 mm pipe, and I'll just take the same pipe. For example, this pipe ID is 436, right? 436 pipe is a PVC AC pipe of 250 mm dia, pipe number 436. Same thing if I go to 2044 scenario, make it current. If I click the same pipe, see here, pipe number 436, it's HDPE 250 because we have changed everything to HDPE, right? And it is a replaced pipe, right? So this way we have to do the model. So here you can add your reservoir which is there at this junction. Okay, you have added the reservoir here. Okay, okay, this reservoir was by mistake, so I'll just delete it. Okay, so you have added the reservoir at its place. So this is where you have to do your modeling, right? In the child scenario, in the 2044 child scenario, is you do all the modeling, change the diameters, change the pipe type, do anything here, right? And the base scenario should be left untouched, so that we will get to know in existing what is the scenario, right? Base scenario is nothing but the existing scenario. Here you will get to know what was the earlier existing pipe, and once they come to 2044 scenario, they will get to know what it has been replaced with, or it has a new pipe there. For example, this is replaced pipe, HDPE replaced. For example, if you click this pipe, you can get to know that it is a new pipe, right? So do all your modeling here, create the Thyssen polygons, and load build your 2044 water demands, and carry out your modeling. So once 2044 you have optimized the model and fixed all the diameters here, your model is ready, your design is ready for 2044 demand. Once this is ready, we just have to check the same model with 2018 and 2029 water demands. That's just for checking purpose. After you have completed your modeling and optimization for 2044 demand, just go to 2044, right click, create a new child scenario of 2044 and name it as 2029, right? If you go to this, make this current. If you go to 2029 scenario, again your model will be there like that. It will all inherit all the properties, all the model, everything from the 2044 scenario. All you have to do here is change the demand. Base demand, click here, go to new demand. Okay, 2029 water demand. Okay, and create your demand here. Okay, again generate, you'll have the same Thyssen polygons. With the same Thyssen polygons, just add the new 2029 demands and run it, and just keep it that way just for checking. Same thing we have to do for 2018 demand. Right click on 2029, or rather right click on 2044, right click here, new child scenario, right? 2018. Make sure you make a child scenario of 2044 and not 2029, right? Child scenario of 2044, right click, make current, again demand here, new demand, 2018 demand, give a name 2018 demand, and now again load build. Using load builder, create Thyssen polygons, billing meter aggregation, Thyssen polygons, and everything, and assign the 2018 demands here and run it. Okay, make sure to make a child scene of 2044, so that in case you go back to 2044 design and change any diameter or pipe here, the same changes will be reflected in 2029 and 2018, right? 2029 2018, the same thing will be reflected. 2029 make current, 2018 also make current, right? So 2044, for example, I'll just give an example for this as well. For example, if you take this pipe, it is HDPE, right? HDPE 250 mm HDPE pipe. Same thing in 2029. If I go to the same pipe, it is HDPE 250. Suppose in 2044 I want to change this pipe to 300 mm, right? So in case I change this to 300 mm, the same thing will get reflected in your 2029 and 2018 as well. For example, you go 2029, make it current, and click on the same pipe here. As you can see, it has been changed here as well. So if you just to make your design final and your model final in 2044, everything will get changed automatically in these scenarios as well, right? In 20, I'm in 2018 now. If you select, see the change has been done, right? So all you have to do is, I'll just brief up everything which has to be done from the beginning. In the base scenario, just import your existing pipes and go to pipe table, and all the existing pipes you give the comment as replaced, right? See, everything is replaced, right? The AC and PVC, give it as replaced. Then go to 2044 scenario. In base scenario, as I said, only existing pipe should be there. Then go to 2044, make it current. Here, change all the AC and PVC pipes to HDPE pipes, and put a comment saying it is replaced in the pipe field 1 column. Put it as replaced, and then import the new pipes. And again, after you import the new pipes, make sure to put a comment as new pipe in the pipe field 1 for all the new pipe created, right? So that we'll get to know which pipe is replaced from the old one and which pipe we have put a new pipe there. Then continue with your load building 2044 demand, and then model the whole thing, design the whole, optimize the whole system. Once everything is done and final, just create a child scenario of 2044, make it 2029 child scenario, put 2029 demand here and run it. Make a one more child scenario of 2044, 2018, that is, load the water demand of 2018 and run it. This is for checking. Once this is done, it is done. So for example, for 2044, if we check the pipe table, we can get to know each and everything. For example, here it is. We can say that, okay, pipe number 525 is ductile iron or whatever after a model, and it is a new pipe. So here we can easily get to know HDPE is replaced and everything. For example, this pipe, you want to discard this pipe altogether, right? Just go here, make it inactive, make this pipe inactive, and in the comment section, just put it discarded, right? So this pipe has been discarded. So the same thing in the pipe table, we will get to know which is discarded and which pipe is being retained. So these are all the new pipes, and here you can see one pipe we have been discarded, right? This pipe is discarded and replaced pipes. So this is how we'll get to know what is the current base scenario there, what is the current existing pipeline, and then which pipes have been replaced, which pipe has been retained, which pipes have been discarded, and then which are the new pipes, right? So if this is done, I think that's about it. This is a basic requirement, and it looks easy to do, not an issue with that. So yeah.